Hello everybody, today we are going to discuss about the multiplication of light into the universe. The reason why we are going to discuss about this is somehow very simple. When we look into the universe, even at far distant galaxies, we see stars shooting light coming at us, but somehow this is spread by a sphere. So the question is, if I have these beams of light moving away from each other, at this distance increasing with time, shouldn't I assume that after a while we are no longer being able to see the star? It should be something like this. After millions of years, the light from this star coming at us should be like this. It should be one beam of radiation in this manner, another one in this manner. So if I shoot light in all directions, and I am very close to the star, if I have a planet here, let's say 1 hour of light, the photons will hit me for sure. But if I am very far and the rays of radiation, the rays of light move away, after a while I should no longer be able to see the star because of this effect. And I'm going to look into the universe with a telescope and I will see nothing. But we never see that effect. Even after billions of years, we can see stars billions of years old. How can that be possible? What's happening? Why, no matter how far we are into the universe, we get to see all stars? What's happened with light? There is a multiplicatory effect. What's happened with the photons? No matter how far we are into the universe, we somehow get to see all the stars. So we think. And I think it is like this. We get to see all the stars, but we have to explain how come light hits our telescopes no matter where we are into the universe. Even one day after the present day, if I'm looking at the stars, they will still be there, although the planet moved a little in that one day. So if I am more over here, let's say after a while, there will still be some beam of radiation hitting me. How we can explain that? Well, we have to see exactly how this works regarding the trajectory of the light. Now, even if you are in a curved universe, or like some people say in a flat universe, this is irrelevant because the photons go in all directions. So the question remains, how come after billions of years a tiny little photon can still hit our telescope? How can that be possible? Well, if initially we have a star which has this diameter, and after billions of years the photons are covering some billions of kilometers, it means there must be some sort of multiplicatory effect. Now, we know that radiation is somehow a reverse sphere. So we have two situations with reverse spheres. It's either a reverse sphere which is around a point of mass which gives gravity, or a reverse sphere which has nothing in the middle. The situation is not exactly the same. They are both on the other side, being made of radiation, but they behave differently. Now, if we are in a case of mass and we have a force all around us, this force right here cannot penetrate this surface and it stays fixed. Other way of saying it, the distance from here until here, this distance is always constant. How do we know this? Because if this is a planet, this is our Earth, the gravity is always constant. It doesn't vary. It's not bigger or smaller, and this force doesn't go anywhere or get smaller. It's constant. And it's constant because of this surface. Now, this situation is somehow very simple. But in our universe, when we have, let's say, 100 spheres of mass, we have 100 spheres, reverse spheres surrounding these spheres of mass. But you also have some billions of reverse spheres which are not made of mass in the middle. They don't have a mass to surround, and they behave differently. Another way of saying it, if I have a reverse sphere, but there is no mass in the middle, how does this behave? Like I've said before, things on the other side have the tendency to overlap. And this force right here that you see It's in fact this one. We have to move it. This one moves, and its fact is right here on the other side. This force right here is the one from here, which in the absence of the sphere, it passes, and we have to put it here. So all these forces somehow pass to the center and hit the other side. The question is, in this case, can I apply the same concept of a fixed, let's say, a distance, not diameter or radius? If this is constant here, will this be constant? Because in this case, there is nothing stopping me from expanding. In this case, I have the sphere, but in this case, I have nothing. So the situation is slightly different. My understanding is that a photon like this one has a tendency to expand. It doesn't mean it expands automatically, because at some point, I have the feeling that I will be too big and I will no longer be coherent. I will somehow lose my identity and I will no longer be able to stay as one element. What is even more simple, if we look into the laboratory, if I turn on a beam of light, it stays as a line for, let's say, 5 meters. And I don't see any spread in those photons for 5 meters. So for sure, this mechanism, it's either very small or it's not at all. But the problem remains. If I have this photon moving like this into the universe, and another one moving like this, and another one moving like this, eventually, if they spread, they miss our planet. But we never see that happening. So something is happening with this photon. It increases in size, very small. It either multiplies itself, but I find this very strange. We don't see that happening. Or there is another element, which is curved space itself multiplying this photon. Like I have showed you already, in our universe, that we have this side with mass and the other side with radiation, the space at subatomic level moves, and the initial Big Bang, which created the universe, also moves at subatomic level. And that happens with the photon. As the photon travels at subatomic level, the curve at subatomic level somehow eats this photon and spreads it into little pieces, increasing its size in all directions. Now, this mechanism is somehow very small and difficult to be detected on small distances and for short periods of time. But on long distances, the mechanism should be like this. If I were traveling with this photon in a flat universe, this will always be the same. It will never vary. But in a flat universe, eventually, I will no longer be able to see all the stars. That never happens, which shows to me that this photon somehow increases and we get to see all the stars. That is what is being created by the space at subatomic level. It is the only explanation we can possibly give in order to explain how come we get to see all the stars, although they are very, very, very far. This is a concept which brings me to the conclusion that the subatomic level of space somehow allows this kind of elements which don't have a sphere in the middle to expand. What is this expansion after all? This is distributed gravity. If I have here gravity, but gravity stands still, I have to say this gravity is concentrated onto this sphere. But here I have nothing in the middle. So if I have gravity, where is the gravity exactly, which we don't even get to see it or measure it? Well, the gravity is not concentrated, it's distributed. And it's everywhere, right now in this room. But these two kinds of gravity, they do not interact each other. This gravity, which is right now in this room, the gravity of the planet, doesn't interact with the distributed gravity of light. That is dark matter. What the scientists are looking for, a tiny little sphere made of mass. I have to say it once again. You will never find it, because there is no dark matter. It's invisible, it is not matter, it's distributed gravity. What you are looking for is for this kind of reverse sphere distributing gravity. Now, this distributed gravity is somehow a very small value, but it's everywhere. if there is an accumulator effect, we have to say this is very difficult. We only see its behavior as it spins a galaxy. Right now in this room, we have this effect, but it's difficult to measure, especially because of the presence of this effect. Once again, they do not interact. This is a different mechanism. And the reason is why it behaves like this in this distributed manner is because it doesn't have any mass. The light and radiation generally doesn't have any mass. There is no sphere of mass here in the middle, because if that would be the case, even if a tiny little sphere will be here, the photon will behave like this. It will not expand and we will not see all the stars. The fact that we get to see it allows me to think that this mechanism allows radiation to expand a little with time, but a little that is enough for us to see all the stars no matter how far they are. And this behavior of a reverse sphere without a sphere of mass in the middle is fundamental, because my understanding is this is what is dark matter all about. It's a distributed gravity which travels into the universe with distributed elements, and distributed elements are only those reverse spheres who don't have mass in the middle. Radiation, another kind of light, let's say, each one of us of that has this behavior. This is what I wanted to say. I wanted to explain very simple that we have two kinds of reverse sphere in this universe. Once we know how they work, very simple because of the presence of mass and generates concentrated gravity like our planet, and those who do not know, we don't know exactly how they work because they generate distributed gravity, which is dark matter, like you say. This is what I wanted to say, and I think I am close to reality. If you think that I'm somehow different, please tell me and I will answer back. Thank you for watching.